Hello and welcome to the fourth video of Module 6. In this video, we'll start using the standard normal curve to begin solving a few problems. In particular, this video is going to focus on the steps for forward problems that only incorporate a z-score. Let's see what we mean by that. After we determine a z-score, we can use a standard normal curve table to assist us in finding probabilities on the normal curve. Remember that a probability density curve tells you the probability by giving you an area of a region. And the standard normal curve table is going to give us those kinds of areas. Here's what that table looks like. This is a standard normal table. The table comes with two pieces. On the left-hand side, we have a table if we have a negative z-score, and on the right-hand side, we have a table if we have a positive z-score. The best way to become familiar with the tables is through working a couple of examples. So, pretend for a minute I had a z-score of negative 1.63. Here's how I would look up that z-score on my cumulative normal probability table. The first piece of the z-score I'm going to look at is the digit in the ones and the tenths place. In this case, that would be the negative 1.6. If I look all the way on the left-hand side of the table, in the column that's marked Z, it starts with negative 3.7 or less, negative 3.6, negative 3.5, and so on. So I'm going to read down that first row there until I find a negative 1.6. That's going to tell me which row of this table I need to look in. To determine the column to look in, I look at the very last digit of the z-score. In this case, the last digit of the z-score is a 3. If I read across the top of this table, it has 0.00, 0.01, 0.02, and so on. Now, this is a little bit confusing with all of those zeros there, but the big takeaway is find whichever column heading has the same number as the last digit of your z-score. In this case, since our z-score is ending in a 3, I need to look in the column that involves the 3. Now, the reason the table is set up this way is because if I add 1.6 plus 0.03, I end up with the number 1.63. So there was an idea behind this in the table, but it can be a little bit confusing. So if the zeros are confusing you, you can just ignore them kind of in that top and think of it as the 0, 1, 2, 3, and so on. In any case, where this row and this column intersect is what we're interested in. This 0.0516 is the number we want to grab from this table. Here's what that represents. Notice the little picture kind of in the top right-hand corner of the positive and the negative z-score tables. See how the shaded region, that gray region, is to the left-hand side of the z? That's because the table tells us the area of the standard normal curve that is below the z-score that we've looked up. In other words, this table tells us that there is a 0.0516 probability that you will get a z-score that is smaller than negative 1.63. In other words, about 5.16% of values on the normal curve are less than negative 1.63. We saw something similar with our empirical rule, right? So if I had a z-score of negative 3, there was a 0.15% chance that I would be below a z-score of 3. That was one of those special values. So this table is going to give us values for more than just whole numbers of standard deviations away. Let's look at a similar example using the positive side of this table. Suppose I had a z-score of a positive 0.37. Take a minute and see if you can look up what the value on the table is that's going to correspond to this z-score. Let's see. If I look at the z-score, the first part of the z-score is the 0.3. So that means I'm going to look in the row for 0.3. Then the last digit of the z-score is the 7. So that means I'm going to look in the column that has a 7 in it. And where the column and row intersect is 0.6443. This means that about 64.43% of the values are less than a z-score of 0.37. Now that we've had some practice using the cumulative normal probability tables, let's look at a few examples. And first, we're going to talk about the steps on how to complete larger scale problems. Here are the steps for completing what I like to call forward problems. A forward problem is a problem that asks you to find a percent, a proportion, or a probability, and you'll generally be given either an x value like a data value, or in the case of these examples today, z-scores. Here are the steps for these problems. First, you need to find the z-score, rounding your value to the nearest hundredth. Now, sometimes you'll be given a z-score, so step 1 is really fast, and other times you'll have to use the z-score formula to determine the value. Once you have your z-score, then it's suggested that you draw a picture of the standard normal curve. When you draw a picture, make sure to label the z-scores and shade in the region you're interested in learning about. The third step is to use the table, and we're going to use it the way that we were just doing in the previous examples. We're going to look on the outside row and column, see where they intersect on the inside of the table, and that will tell us an area. Lastly, we need to find the indicated value. If we're looking for a probability that x is less than some number, then it's really easy. Whatever you get from the table is going to be your answer. If we're doing a between problem, then we're going to subtract 2 values from the table. And if we're doing a greater than problem, we'll subtract the number from the table from 1. We're going to do one example of each of these 3 types of problems. So we're going to do an example of a less than, an example of a between, and an example of a greater than. So let's see how this will work. In this example, we've been asked to determine the probability that a z-score is less than or equal to 1.81. The first step is to identify any z-score. And in this case, because z was used in the inequality, we already have our z-score. Now, don't let the inequality mislead you. This 1.81 is the value that we're going to be using for z, even though it says that z is less than or equal to 1.81. The reason we're going to use 1.81 for z is because this z is kind of like the cutoff point. So 1.81 is the cutoff point for the values we're going to be looking for. Step 2 is to draw a standard normal curve. Now remember that the standard normal curve has a mean of 0, which is why I've drawn a 0 in the middle here. And it has a standard deviation of 1. What that means is when I go to graph a z-score, some things to bear in mind is that positive z-scores are going to be placed to the right of 0, while negative z-scores will be placed to the left of 0. Additionally, if I have a z-score that is close to like 3 or 4, it's going to be all the way at the end of my normal curve. And if I have a z-score that's like 0.1, that means it's going to be pretty close to the 0. In this case, the z-score we have is 1.81. So I'm going to estimate it about halfway, a little bit more than halfway along this interval here. Then, since we were asked to determine the probability that z is less than or equal to this 1.81, we're going to shade to the left of the 1.81. This is because this red region represents all of the values that have a z-score that is below 1.81. Now, the last thing that I like to add to my picture is an arrow that points to the left. The reason I like to use an arrow that points to the left is because it helps to remind me that any values we look up on our standard normal table are going to be areas to the left of the cutoff z-scores. And that brings us to step 3. Step 3 is to look up the z-score on the table. So I have a piece of a table here for reference. Our z-score is 1.81, so I'm going to look in the row for 1.8 and the column for 1, and that gave me this 0.9649. So I'm going to take that 0.9649 and write it on the line that I gave myself underneath my standard normal curve. What this means is that 0.9649 of the values are below 1.81. Since we were asked to find the probability that z is below the 1.81, step 4 is really easy. It's just going to be the value we found from the table. And that's it. Let's do a slightly more complicated example. Not that this wasn't complicated enough, but we'll do a problem that's got maybe one more step to it. In this example, we want to find the probability that a z-score is between the values of negative 3.25 and negative 0.25. Now, one of the things that makes this example a little bit trickier than the previous one is that when I go to identify the z-score, we actually have 2. Because we're interested in z being between these two values, a negative 3.25 and a negative quarter, we actually have to use 2 z-scores. One of the z-scores will be negative 3.25, and the other z-score will be a negative 0.25. So when I go to graph a picture, I need to make sure that I graph both of the z-scores. Since both z-scores are negative, I'm going to draw them both on the left-hand side of 0. Since negative 3.25 is pretty big, notice that I've drawn it all the way at the end of the curve. Since negative 0.25 is really close to 0, that's why it's drawn pretty close to 0. To complete the picture, we'll shade in between these two regions, and then we'll add arrows pointing to the left. Whenever I have a between problem like this one, I always draw the arrow that's on the left first, and then I draw the other one. This way, I can draw the arrow that's further to the right underneath the arrow on the left if I need to, and that'll give me just a little bit more space to write my answers. This concludes step 2. Step 3, remember, is to look up our z-scores on the standard normal table. Because we have 2 z-scores, we're going to have to look up both of them and write both of them on those arrows. When I look up the negative 3.25, I get 0.0006. That is extremely small, right? This is less than, this is 0.06%. So not 6%, 0.06%, super tiny. When I look up negative 0.25, we end up with 0.4013. So I'll write 0.4013. Here's what these numbers are telling me. The 0.0006 is the area of the curve that is to the left of the negative 3.25. The 0.4013 represents the shaded region that we want to find, plus that 0.0006. It represents everything to the left of the negative 0.25. So if I want to find the shaded region, one way that I could do that is by taking that bigger number, the 0.4013, and subtracting the smaller number, the 0.0006. That's going to be our step 4. Whenever you have a between problem, you need to take the bigger area and subtract the smaller area. If you have these in the wrong order, then you'll end up with a negative number, and you'll know you made a mistake since probability can't be negative. When I subtract these values, I end up with 0.4007. Suppose a scientist determines that an event is unusual if the probability is less than 0.05. Would it be unusual for z to be greater than 3.27? So for this example, unusual means weird, right? So a scientist says that it's going to be weird, it's going to be odd, if something has less than a 5% chance of happening. So we need to investigate, is there a less than 5% chance for a z-score to be more than 3.27? So let's work it out. The first step is to identify the z-score. Since we're comparing z-scores greater than 3.27, that means we're going to use z equals 3.27 for this problem. The second step is to draw a standard normal curve. So here's my standard normal curve with 0 in the middle. 3.27, our z-score, is going to be really far to the right-hand side. And since we're interested in z being greater than 3.27, that means I'm going to shade to the right of this value, that teeny tiny space. To finish off my picture, I'm going to draw an arrow pointing to the left. Do you remember what comes next? Step 3 is to look at the standard normal table. In this case, when we look up a z-score of 3.27, what's the area that we find? We should find an area of 0.9995. This makes sense that we would have 0.9995 on the line here because this represents the area below 3.27. Since 3.27 is super far to the right of the normal curve, it makes sense that 99.95% of the values would be below this number. For step 4, we need to find the area of the shaded region. Unfortunately, we don't have that yet. What we found is the area of the unshaded region. The region below 3.27 has an area of 0.9995, but we need to know the area above it. In other words, we need to know the complement. Remember that to find the complement, you can just subtract a probability from 1. So in this case, we're going to subtract 0.9995 from 1. And this will always be the case for greater than problems. Whenever you're looking for the probability of a value being greater than something, you're going to subtract the probability from 1. When I complete that step, I end up with 0.0005. This time, however, we're not done with this problem because we weren't asked specifically for probability. We were just asked, is it going to be unusual for z to be greater than 3.27? The scientist determines that an event is unusual if the probability is less than 0.05. In this case, since the probability is only 0.0005, it is significantly less than 0.05. This would mean that yes, it would be unusual to have a z-score that is more than 3.27. Thanks for watching this video on the standard normal curve. In the next video about the standard normal curve, we're going to be taking the problems that we just did and adding one extra step to them to begin with. In other words, instead of starting out with a z-score, we're going to start out with an x. Thanks for watching and have a great day!